doing here, we once again have to go to page 14. And after doing a couple of years worth of these past papers, what you sort of realize is that you got to use what comes before the double angle rule would be cos A plus B. Okay? And you look up cos A plus B on page 14 of your maths tables. And what you're going to get is cos A cos B minus sine A sine B. Okay? And then it's a very simple thing of replace B with A. So you're replacing B with A. So you're just going to get cos A plus A, which gives you your cos 2A. And then you're going to have cos A minus sine A sine A. And you're just going to get cos squared A minus sine squared A. And that's the cheapest couple of marks you're going to get on one of those proof questions. It's reasonably handy, okay? Now, next question. Sine theta over 2 is 1 over root 5. Using the formula cos 2A equals cos squared A minus sine squared A, find the value of cos theta. Okay, no bother. I think we have an idea here. All right. So, if you imagine that A equals theta over 2, therefore 2A would be 2 times theta over 2, which in turn would be theta. And then if we sub into this formula here, it's going to be cos 2A is theta, and it's going to be cos squared theta over 2 minus sine squared theta over 2. And for those of you who don't know what cos squared theta over 2 means, it actually means cos theta over 2 to be squared minus sine theta over 2 to be squared. All right. Next thing I'm going to do is go and draw a right angle triangle, okay? And the right angle triangle, we have sine, and using the rule SOHCAHTOA, SOHCAHTOA, we know that sine is opposite over hypotenuse. So we know that that's 1, and that's root 5. Oh, sorry, 1 and the hypotenuse is root 5. And we know that this is theta over 2. Yeah, we should figure out what the adjacent side is. So what we can say is that root 5 to be squared is equal to 1 squared plus x squared. 5 equals 1 squared plus x squared. This means x squared's got to be 4. And then x therefore equals 2. So we know that the adjacent side is 2. Therefore, we now know that cos theta over 2, which is adjacent over hypotenuse, is simply 2 over root 5. And this simply comes into 2 over root 5 squared minus 1 all over 1 over root 5 squared, which is hopefully going to be 4 over 5, take away 1 over 5, which should give us an answer of 3 over 5, which it does, and that actually went for 10 marks. So for this question, what I'm thinking is, I'm thinking of just basically saying tan x equals minus root 3, and x is equal to b plus 150 degrees. I'm then going to do ASTC. ASTC, and we know that tan is negative. So if tan is negative, it must be the quadrants S and C. And the answer is given in degrees. Now, the rule for the S quadrant is 180 minus your reference angle, and the rule for C is 360 minus your reference angle. The reference angle is inverse of the positive number, so R equals tan inverse root 3. Okay, not minus root 3, but plus root 3. Resume. Now, what we're thinking here is we could have done what we could have done is tan inverse root 3, shift tan inverse root 3, 60 degrees, okay? So 60 degrees. Going to put the 60 degrees into these two formulas here. And there's going to be two answers. There's going to be 120 and 300. But remember, I'm not looking for x. I'm looking for b plus 150, which equals x, because the two of these are equal to x. So that means that b plus 150 equals 120. So b, in fact, is actually negative 30. Now, b equals minus 30. But what is minus 30? At the end of the day, plus 30 would be clockwise, and minus 30 is anti-clockwise. And that would put me at the 330 mark. So this means that b is 330 degrees. And for the second question, where equals 300, b plus 150 equals 300. This must mean that the b value is 150. Okay, now that's one way of doing it. The other way of doing it, and once again, doing questions in two different ways is a great way of enhancing your ability to deal with questions on the test. So a lot of time, we're going to actually try and do it two different ways. We could use the formula tan A plus B. The reason why I'm taking that is it's the addition of two angles. So that is the formula tan A plus tan B minus 1 minus tan A tan B. Okay, and what I could say here is that B is 150 degrees, ergo tan B, or tan 150 degrees, would be tan B, and put tan 150 into the calculator. That's minus root 3 over 3. We can just keep as that. At the end of the day, we would probably end up using the calculator. So this is tan B plus 150. So anywhere I see A, I'm replacing it with B, and anywhere I see B, I'm replacing it with 150. So it's going to end up to be tan B plus tan 150, which we know is, what's tan 150 again? Oh, it's minus root 3 over 3. So it's minus root 3 over 3. And then the other one is 1 minus tan A, and then minus root 3 over 3. We're about to get this, so that's tan B again, not tan A, tan B. A gets replaced with B. Now, we're going to have to deal with this now. So it's going to be tan B minus root 3 over 3. And then on the bottom, it's going to be 1. The two minuses make a plus, so it's going to be plus root 3 over 3 tan B. And we all know that this has to equal minus root 3. A lot of square root signs in here, okay? And I think this is probably the more difficult method of the two. What I'm going to do is I'm going to allocate everything a common denominator. You're going to have 3 and 3 here to make the 3 on top. You're going to be 3 over 3 as well. Okay, now ignoring the left-hand side, I'm just going to concentrate solely on the right-hand side here, okay? This is going to turn into 3 tan B minus root 3 all over 3. And the denominator part, which I'm highlighting in green there just a second ago, that's going to be 3 plus root 3 tan B all over 3. Now remember the trick we taught you with fractions. If you've 2/5 divided by 3/4, you bring the 3/4 to the top and you turn it upside down. That's what you would have learned at juniors there. So you're going to take that bottom green fraction, you're going to bring it to the top and multiply it. So it's actually going to be 3 over 3 plus root 3 tan B. This is all the fun right here. Okay, now, so all of this I've just done. Just going to get rid of all that, just for the sake of, don't do that on the test, but just for the sake of space. And we know this all equals minus root 3. Okay, the 3's cancel. And what I'm going to be left with on top is 3 tan B minus root 3. And on the bottom, I'm going to have 3 plus root 3 tan B. And that equals minus root 3. And here's what we're going to do next. we're going to bring this up and multiply it. Okay, 3 times minus root 3 is minus 3 root 3. Root 3 tan b multiplied by a minus root 3. The two root 3's interact with each other to become minus 3. Minus 3 tan b. Then on the other side is 3 tan b minus root 3. Then when we bring everything onto one side, we're going to have this minus 3 tan b becomes a plus 3 tan b. And then it's going to be 6 tan b on the left. This root 3 comes over and it becomes a plus root 3. That's going to be minus 2 root 3. And then we're going to divide it in. So what's it? Minus 2 root 3. That's minus root 3 over 3 equals tan b. Okay. Now, the fun job with this one is we're also going to do ASTZ. So it's actually going to be the exact same thing. And I don't know why we bother doing it this method, but here we are. We're once again in the S and C version, which is 180 minus R and 360 minus R. The R value is the tan inverse of the positive. Once again, that's a learned off method, which is 30 degrees. And lo and behold, that B value will give us 150 when R is 30 and 330, which is the same answers I got in the last question. The ability to do it 2 different ways is very important.